Hello, welcome to my talk, Common Security Risk in Frontend Applications, and today I'm going to talk about how to build safe and secure software. A little bit about myself. My name is Dan Neciu. I am a tech lead and co-founder of the Career OS. I'm originally from Romania, but now I live in beautiful sunny Barcelona. I like speaking, writing about security, accessibility, and testing. And if you want to read more of my work or browse my content, you can follow me at Twitter at Neciudan. And in my career, I've worked on all three big frameworks. I've started with Angular, then I moved to Vue, and now I'm working fully with React. I also have a very lovely cat named Laplace, which is named after the French mathematician. So to start you off on this journey, let's imagine we are in a galaxy far, far away. So you have a nice cozy desk job at one of the biggest companies in the world, Death Star Incorporated. And there's some noise outside, some skirmish or whatever, but you pay it no mind. You are an indestructible juggernaut, the size of a moon. Nothing can bring it down and stop your workday. Nothing, of course, unless somebody intentionally created a flaw in the system. A flaw so tiny that nobody would observe it and can bring the whole thing down. A single blast by a space wizard brought down a company that took decades to build. Now, this time it was intentional, but what if it's not? What if trying to design the perfect system and because of deadlines or stress or whatever causes you to add unintentionally a similar flaw in your system? And security for most front-end engineers is something like Star Wars, very far, far away. We are using the latest tools and technologies and frameworks, and we think surely that's enough. You can trust your coworkers, you can trust your framework of choice, and you can trust some well-maintained third-party library. But the reality of it is that you shouldn't trust no one. Because just like how the Death Star was minding its own business and it was a majestic piece of technology, floating from planet to planet, leaving beautiful pieces of Alderaan floating in space, and now it's gone. Destroyed with a single shot in an exhaust port because of a carefully placed backdoor vulnerability. Now, if you'll allow me, let me explain how to avoid another Death Star disaster from happening. And the first thing that we should think about is that there is a widespread mental model called second-order thinking, which says that when coming up with a solution, don't focus just on the solution itself to your problem, but also on the effects of the solution will have across the system. So when you're building a feature or a project, think in consequences. What are the first-order consequences, good outcomes and bad outcomes? And then think about second-order consequences and map them out. That way you can see when you're building something what can actually go wrong. Now, because the biggest problem to our beautiful working system is us, the developers, because we think in solutions but not in consequences. And one way to prevent this from happening is to implement threat modeling into your feature building process. And there are 5 easy steps to threat modeling. You and your team get together before you start building a feature or a project and do the following. Step 1, you set objectives in written format so you can measure your success. Step 2, you visualize what you are building. So your feature, you see it used by users, you see it how it would look like in production. Step 3, you start identifying threats. What can go wrong in your application? And here you can be as creative as possible and even go above the boundaries of what is possible inside your system. And then you mitigate. You create a series of tasks that are what are we gonna do about it to make sure that what we found in the previous step does not happen to us. In the end, we implement our solution and then we compare your results with your initial goals. We validate our assumptions. But to do threat modeling successfully, everyone in the team must be aware of the most common security risks so you can plan for them. And today I want to focus on the 4 most common security risks in front-end development, which are backdoor products and libraries, cross-site scripting, security logging, and spoofing. And let's start with backdoor products and libraries. There is a very popular joke in the JavaScript community that when scientists have started mapping out the heaviest objects in the universes, of course, they started with the sun, then the neutron star, it's heavier than the sun. Even heavier, it's a black hole. And finally, the heaviest object in the universe is the node modules inside a JavaScript application. Now, of course, this is a joke, but you can see that why node module is getting bigger and bigger is because the entry point for node modules is our package JSON. And our package JSON is also the entry point for the most dangerous vulnerabilities out there. It might also need a sign that says, "Here there be dragons." And why is that? Because you usually want to use a popular library or a third-party tool that is just perfect for the feature that you are building. And why spend time building a feature when you can just reuse something that's already built? And with a simple npm install, you are opening yourself up to danger. Now, even if Amazing Library does not have any vulnerabilities itself, it may use a library or a package as a dependency that might be vulnerable or a direct exploit. Now, thankfully, npm provides an audit of every package, and it gives a score of low, medium, or high to each vulnerability it finds. You then can run npm audit fix or npm audit fix force, like in the slide, to fix your packages. Now, I want to stress that this will attempt to fix your packages, because in the JavaScript world, things are never simple. Like this, what happened to me. I had 22 high severity vulnerabilities. I ran npm audit fix force, and now I have 33 high security vulnerabilities. And this is a common thing to happen in JavaScript. Now, luckily, GitHub also has a vulnerability checker called Dependabot that checks each PR for new updates or if you are introducing a package that might be vulnerable. It also does, it automatically creates PRs to bump vulnerable versions for you, explaining the release notes, changelog, and what can break. Now, unfortunately, both npm and Dependabot catch problems only after packages have been flagged as vulnerable. So by the time npm warns you, it might already be too late. But there are a couple of best practices before installing a package. The first is to check if the library package is well maintained. Check their issues on GitHub and see how soon the maintainers respond to requests. Do regular checks using npm audit, may be included in your CI/CD pipeline, and then install Dependabot, Sneak, or other security audit software to keep your project safe. Stay ahead of the game. Check websites or Twitter accounts that report common vulnerabilities in the web. But most importantly, the one thing you can do is, of course, constant vigilance. Practice awareness and see what you're installing. Just don't install everything out there. Secondly, let's talk about cross-site scripting. Now, cross-site scripting, or XSS, has been in the OWASP top 10 every year for the past decade. And in 2022, it has reached the 3rd position. So this website, OWASP.org, talks about the most common vulnerabilities in the internet, not just front-end vulnerabilities. And you can go there and they explain to you what each does, how to protect yourself from it. And they also have this top 10 of the most common that happen every year. So hooray for XSS for being on 3rd position last year. Now, an XSS vulnerability happens when an attacker manages to inject malicious code inside an application. Now, this malicious script is then executed by the normal user's browser, and the code can access cookie data, local storage, or other browser-related information. A typical example is a comment form component rendered inside an article. So you have an article page, and at the end of the article, you want to have a comment section where normal users can give feedback on the article they just read. And an attacker could abuse this by, instead of writing text, they would introduce, for example, let's say a script tag. And when this would be saved in the database, and when other users would open the article, now if the article is rendered in an element, the script will execute. So if you're using inner HTML, like VHTML for Vue or dangerously set HTML for React, it's gonna execute that code. Now, typically you will do this, you would use inner HTML rendering functions because you want to add markdown to your comments and you want to showcase which text is bold or italic and so on. Now, front-end frameworks are pretty smart in detecting script tags and prevents them by default. Unfortunately, attackers rarely use them. Instead, they usually do something like this. They add a piece of text and then they write the markdown for an actual image. And inside the onload or on-error methods, they're gonna introduce the malicious code. So imagine you're writing this image, and in the onload method, they are gonna use a fetch for their website, and they're gonna post the contents of your local storage, your cookies, your user account, anything that they can. And this is pretty scary, right? You can browse around the website, and with a simple image inserted maliciously, it can take all your cookie and local storage information. Now, the good news is that this is totally avoidable. The recommended solution is to not render HTML for user-generated content. That way, we all sleep better at night. But if you absolutely must use it for some reason only you and your corporate overlords know, you must sanitize the user input. There's a popular library called Sanitize HTML that handles this very well, and it has variations for Vue, for React, and for Angular. Now, another best practice is to also validate proper user input on the backend side and prevent malicious code from reaching the DB. Now, the year is 2023, and of course, we're measuring everything. We're measuring page views, clicks, events, errors, how much the user is scrolling. We have heat maps to see where the users are going, and all sorts of user-related data that we can later use to determine if what we're building actually works. And unfortunately, as in such cases, we sometimes might send a little too much data to our third-party vendors. Because typically we don't store that data ourselves. That's a huge amount of data. So we use third-party SaaS tools like Datadog, New Relic, Sentry, even Google Analytics, or any other number of observability tools. And that means that every link that we are sending from our front-end client is stored in a database that you have no control over. And what we're sending that might be considered a security vulnerability is like reset password tokens, promo codes, or checkout generated links. So why does this happen? Because we're using query params in the URL for sensitive data. We have a URL like this, https yourwebsite.com/reset password, and then we're giving it a query param with a token. Now, when this happens, our third-party observability library of choice will log this URL as visited. And if an attacker gets access to that log data, maybe because you have a data leak, the vendor has a data leak, or actual users can see this information, they can get access to these tokens and hijack user accounts, get access to unused promo codes, or visit checkout links and get access to user card or billing information. Now, to prevent this from happening, it's recommended to not use query params and to use fragments instead. Like you can see below, you have your website.com/reset password, and then hash token equals to the token. And when you're going to use this, hashes are normally not logged or persisted in observability tools. And most importantly, it is recommended you audit all your URLs and pages to make sure you do not show user data on public pages. Now, for example, when I might order something on your website, you might redirect me to an order successful page with an order ID in the root. And when I visit this page, I might see order details, my billing information and stuff like that. But if this URL is accessed by someone other than the user who created the order, we must not show sensitive data like card information or the user address. Personally, I would do a really thorough control access system that would not allow other people to see order information. So use hashes instead of query params for sensitive data. Make sure you validate control access to personal data. Try to pick and choose what observability data you are sending to your third-party vendors. Now let's talk about the fourth and final security vulnerability, which is spoofing. Now, phishing and spoofing have gotten very creative over the years. And while both employ similar tactics to achieve the result, to take the user to their own website and try to steal their password or information, they achieve this in different ways. Phishing will normally fake an official email, and inside the call to action, they will redirect you to their website. I cannot even count the number of fake Jira emails or AWS email I have received trying to make me click and steal my password. As you can see here, the number 0800 801 5811 seems like a perfectly reasonable AWS link that you will click on your phone, you will tap it, but it's actually a malicious website. So the best thing you can do is practice constant vigilance, because normally email clients catch this and all you have to do is be vigilant. Check the sender, the content, and that the link you are going to has the correct domain name before clicking on any links. Now, spoofing, on the other hand, is way more dangerous because it takes advantage of your website's flaw to redirect you to another website. Now, think of a beautiful web page where you can add promo codes. And promo codes are usually sent using marketing strategy, and from the email, they would redirect you to your website using a fragment or hash like this: your website /promos, #promo300. And on our page, we want to get that promo 300, which is the actual promo code, and show it in a maybe in a box, bolded, in a beautiful way. And you will probably render this using maybe VHTML or inner HTML, because you would have like an internationalization page where you have multiple languages. So you want to say apply promo code, and in another language change the apply to the correct form. And by using inner HTML, again, in this situation, you have opened up a spoofing vulnerability. A creative attacker can create a very nice looking HTML using your URL parameters like this. So it has your website /promos, then you have the hashtag, and then you have a complete URL that it's actually the one before it, which is a div, promo is, then a break, and a link to another website. And your user might see this and actually click the link because it will assume that it's a normal link on your web page, but it's actually been a vulnerability introduced using the URL and the inner HTML rendering methods. And for best practices, like in the case of XSS, the best approach is to never use inner HTML to render user content or content from the URL or any other medium the attacker can exploit. So to minimize the risk of security vulnerabilities, it's important to follow best practices such as validating user input, using encryption for sensitive data, and implement proper access controls. Additionally, having security login and monitoring can help detect and respond to potential security threats. as well as activating dependency checks in your pipeline, having npm audit and dependabot. And always, and I mean always, sanitize user input and try not to render using VHTML anything that can be abused by attackers, URL, cookies, and user-generated content. And now that we know what the main risks are to our front-end application, introducing thread modeling before estimating and grooming a story is pretty straightforward, and I recommend you do it immediately. So that's about it. My name is Nechudan. If you like my talk and you want to know more about me, feel free to reach out on Twitter or on LinkedIn. You have a QR code with all my information on the screen. And let me also discuss a little bit about the company I co-founded. Every day you hear about a new company doing layoffs, and realistically the most impacted are not the people getting laid off, but actually the juniors and students who are trying to enter the job market. Now, our platform is aimed at helping students and juniors finding the best opportunity by bringing an AI-first discoverability to the job search. We also help them organize the job search and network using our platform, because we found out that instead of just applying to a job on LinkedIn and waiting to get the result, if you start networking and people recommend you for a job search, you have a 30% more chance to hear back from the company. And if you want to beta test our app for free, or if your company is looking for students or interns and junior employees, you can scan this QR code, complete the form, and we will reach out to you. So thank you, and may the 4th be with you.